say some AI model in healthcare is built in United States,
Okay.
obviously on the patient data of their country. And the thing is, in our country, maybe patients have some different clinical parameters, height, weight, hemoglobin, etc. Maybe some different parameters. So their model, which is built, which is trained on their population, will it work in our country at the same accuracy level? That is my
No,
question.
so a very, very valid question. Not always, right? For example, Southeast Asia, you uh, first of all, there is the trait of people is very different now. Even if you go to US, you have Indo-Americans, Afro-Americans, Hispanics, Latinas everywhere, right? I mean, US is a very multicultural country, as you know, and same with India. So the difference between any country and their population is very very debatable now. Any country you go, you see a lot of people in different traits and different things, different height, different biological features and everything.
Yes.
But again, the question you put is correct, because some example, the climate and the way they live, right? For example, Canada, Russia, all these people, they have very different, I mean, their blood itself is different, because their hemostatic is very different, and they have a long winter seasons, long summer seasons. So when some parameters, it won't work with the high same accuracy, right? It will affect, but it is not a deal breaker. What I meant by deal breaker is that doesn't solve you in solving the problem. What you need to do is you deploy the solution. If for example, if I build the product with mostly using 60% of data set in India, and I have to deploy it in Europe, the same product I can deploy in Europe. And what I will, when any company, what they will do is they will assess the new data coming from that specific place. Maybe for a time frame, they both will agree, the client and the product provider, maybe 6 months or 3 months. Then they adjust the threshold accordingly. For example, so threshold are built. Now you just need to tweak the thresholds, right? For example, so you deploy it in the real life settings, then observe the data patterns, then adjust the threshold, because the model is working going to be similar. It's only a matter of tweaking the thresholds. That is how there will be minor inaccuracies which can be resolved. That is in a
Okay.
nutshell.
Okay. Thank you, sir.
Thank you. Thank you, everyone. Janvi ma'am, I mean, we are done. We can wrap up the session then? Hello.
Hello.
Yeah.
Hello.
Yes, sir. Yes, sir. Tell me.
Yes, sir. Completed, sir.
Yeah. Yeah, yeah. We can complete. We can wrap up the
Okay.
session. Thank you. Thank
Okay.
you,
Thank you.
everyone. Thank you for giving me the opportunity. Thank you.
Okay, sir.
Thank you, sir.
Hello, everyone. We have 5-10 minutes before we can start our next session. Let us wait for 5-10 minutes. Our next session will start by 8 p.m. most probably. Welcome everyone to our second session of the day. Dr. Kiran Trivedi has already joined. Let me introduce him to all of you. Dr. Kiran Trivedi is an associate professor of computer science at the University of Wollongong, Gift City, Gandhinagar. With over 20 years of academic and research experience in India and the USA. He has previously served as Northeastern University, Sattel, and Gujarat Technological University. Holds a PhD in human brainwave analysis and is widely recognized for his expertise in artificial intelligence, edge computing, and deep learning. Dr. Trivedi has delivered invited talks at leading global platforms, including UNESCO in France, ICTP Italy, and Georgia Tech USA, and has published more than 35 research papers along with 2 patents. His contributions have earned him prestigious honors such as the Nokia Developer Champion title, the Dr. APJ Abdul Kalam Innovation Award, and the Patient Value Award from the University of Wollongong. He has also received NVIDIA AI research grants and led students team to success in state level hackathons. Beyond academia, Dr. Trivedi is an avid cyclist with over 27,000 kilometers of riding experience, a music enthusiast, and a passionate advocate for innovation and student empowerment. Today, Dr. Trivedi will be sharing his insights on Gen AI, generative AI with TinyML, highlighting current developments, practical applications, and future prospects of this transformative technology. I would now like to invite Dr. Kiran Trivedi to take over the session. Dr. Trivedi.
Thank you. Thank you, Janvi, for the
Thank you
introduction,
very much.
and pleasure being with all of you. And it's happy to see that like more than like 184 participants are there in this FDP at the very late evening today. And I will try to explore as much as I can for all of you, and will try to demonstrate something. So being, I think, one of the last session for today's first day, is it the last one, right, Janvi?
Yes, today
So
it's
I'm
today's
I'm
last
going
session.
to
Yes.
make it some interesting and something like I'm going to demonstrate something hands-on, as well as some of the devices which I have and some of the projects which I recently did. So there would be a mix of PPT as well as some live demonstration, what you can do with generative AI as well as TinyML. So let me share my screen first, and then we'll start my presentation.
Okay, sir.
I hope you can see the screen, right?
Yes, sir, we can see your screen.
Okay. So right now I will little bit modify the title. It's generative AI and tiny machine learning, basically like how we can use it on wearables having an AI capabilities. And again, it's going to be related to voice-driven intelligence on edge devices. So before I start my session, let me tell you something about different terminologies like what is generative AI, what is tiny machine learning, or maybe edge computing, etc. So in general, by and large, when we talk about artificial intelligence, it is all about when we do train, collect the data, and then train the data with some sort of mathematical model and try to bring some model out of that. And when we inference them, or maybe when we use on the computers, that is a normal AI. But when it comes to an embedded system or an electronic chip, where we transfer the model to a very smaller size of the hardware, where there are lots of resource constraints are there, maybe a low computing power, low battery power, or maybe the memory storage, etc. The flash memory is also very less. So in such scenario, if we can run such model, it is basically a kind of a tiny machine learning. So in general, normal machine learning and tiny machine learning, the biggest difference is in the size of the model. So if you take an example of a computer vision problem where you might have a model of say 150 MB, which has been trained on number of images. But when you want to use it for a very small Arduino kind of a device where limited resources are there, so you transform that model to a very smaller size, maybe a 9 kilobytes or 12 kilobytes of model. And that is why it is known as a tiny machine learning. So the recipe or the ingredients for machine learning remains same, but it is all about reducing the size of the model and loading into a chip on a standalone device, or maybe a kind of a handheld device, or maybe wearable device, whatever you name it. So we try to replace the computer with some embedded system, or we try to load it on a maybe a small chip where it can run the model and all the capabilities and functionalities can be achieved. So that is what the tiny machine learning is all about. Now we call it as an edge computing also sometimes, or sometimes we call it as a physical computing. So why do we call it as an edge computing? It is because when you have a full network, say for example, we are connected with internet, there are lots of IoT devices, most of the things, even our mobile phones and everything are connected with internet. And when we use AI systems, basically there is a central server which has a number of models running, and they try to process the information whenever we send it through our devices. It could be anything like mobile phone, whenever we say upload a Google photo to our Google Drive or maybe Google Photos, the models are running at the Google server. And finally, it can find out that what are the contents in the images or what are the objects in the images. So you might have observed that if you open your Google Photos and try to search some images with say bicycle or maybe sunset, etc., the model will be running at the Google server and will find you the solution for that. But when it comes to edge computing, it is at the edge of the network. So say for example, again, the same internet, same devices, everything is there, but the model runs on the device itself. And the best example is the Amazon Alexa, what we use at our home. So the model is basically located or stored or running on the device itself, and it processes everything. So the concept of edge computing is all about running the model on the edge of the network on the edge devices. So Amazon Alexa, Google Home, or maybe Siri, or any other devices, like you have chatbot applications or voice chat devices. These all are basically the edge computing devices, and the models are running on the device itself. The reason is that we want privacy. We don't want to transfer our data to the server. Everything should be processed on the Alexa device, for example. And again, whenever some information is being transferred to the Alexa or maybe Amazon servers, there is a kind of an encryption. So recently I met one of the Amazon engineer from Seattle. He told that whenever you are using your Amazon Alexa at your home, you give some instruction that Alexa play my music, for example. But when it goes to finally in terms of processing for some sort of other maybe a future enhancement of the model, they actually transform the complete audio into a different encrypted form. So they never know that who are the users using our Alexa devices. So there is a privacy, and most of the things are being processed on the edge computing at the devices what we have on the home at the home. So today's session, like I have divided into different part. Initially, just to make some curiosity, I'm going to demonstrate you something, and that is recently I demonstrated one of the Festival of Australia event at various places in India. So I will show you that first. You see different three images over here. So what I've tried to explain here is that, say for example, we human normally communicate, right? So maybe there are two friends communicating, or maybe in our day-to-day life, since morning till we sleep, we talk a lot and we do lots of conversation. So it is all about generating audio, generating speech signals. But sometimes it is necessary that we need to remember those things, that okay, like I got a call from someone from GP Ahmedabad that you have a lecture today at like 8 p.m. in the evening. So there is a conversation happen. So I said, okay, I will join at 8 p.m. But sometimes it is necessary that we want to log the audio for ourselves and we want to process it further. So here is an example of how it has been done. So consider that these two like images being generated through AI, like there is a boy and girl. They are wearing a wearable device which has a camera, which has a ESP32 inside that, and number of things have been included. So if you look at the first boy image, it says that last week you said you want to go to gym. So maybe if you ask that device that, okay, last week what I was talking about, so maybe your device can tell you that you are talking about going to gym. Or maybe at the end of the day, you ask your device that, tell me about summary of today, what I converse with different people. So maybe it can give you lots of, contextual statements from your daily conversation. And again, there is a kind of a privacy being, it's a privacy preserved, I should say, so that it will not record someone else's voice, because we don't have any right to record someone else's voice without the permission. So the device is designed in such a way that it will record only the sound of a person who is using it. So for this girl, like summary of your days, like you paid the fees, you have party tonight, or maybe you are applying for UW India. This is based on the conversation, what has been done so far. But it is not that simple. What do we think? That it is not simply recording them. It uses lots of various services of generative AI to bring all these to a single device. So let us look at the diagram, how it works. Let's say, for example, there is an ESP32 board, or maybe any variants, like maybe you have a Seed Studio, the Zao device, or any other device is what you have. Maybe it has a camera. So what I use is I have a DF robot board here with me. I will show you that. This is the board which I am showing you right now. But if I can show you on the camera, you can see this one. So this is a DF robot board. It has a camera on board. It has a microphone on board. It has loudspeaker on the back side. Even there is a memory card. So whatever I'm going to speak will be recorded on the device itself. Are you able to see this one, or the screen is being shared and that's why you're not able to see that? Okay, fine. Thank you. So let me maximize this one. So what happens? like whenever we are using this device, say a kind of a wearable as a necklace or maybe a wristwatch, the audio will be recorded at some seconds of interval, maybe like 2 seconds, every 2 seconds, or whenever the audio, when the audio is detected, it will start recording. So initially it will record the file, but we need to record into a wave format. So initially the file on the ESP32 board having a memory card, it will be stored into a wave file format. Now, once we have obtained the wave file, we need basically a text because we need to process this text. So finally, there we need a transcription of the text. And if you are aware about the DeepGram servers, they basically provide you lots of voice intelligence. So if you open a website of DeepGram, you create your account, you get some free credits in the beginning, or if you have a plan which has been purchased to use the DeepGram officially, or maybe like if you want to run some business on that, you need to have some sort of credits with you. So using API call, all these wave files, maybe recorded for 5 seconds or 10 seconds, will be sent to the DeepGram server. If you look at the block diagram, there is a cloud shows that there is a DeepGram connectivity. And once it goes to the DeepGram server, DeepGram has a feature that it will identify the audio file and it will transcribe into text. So basically, you will receive a text file back to your memory card into the ESP32. Now, once we have received this text file, we need to analyze, we need to summarize that. Say, for example, if you provide a 2 page of conversation which with someone you were talking and it has been recorded into a wave file, we need only a summary, or we need only simply a context of that particular conversation. We don't need the full text of the audio which has been generated through conversation. So basically it has to be sent to the OpenAI router or maybe OpenAI server, where basically we are sending it to the chat gpt, but we are not directly accessing the chat gpt, but through OpenAI router we are sending this text to the OpenAI router, and it will finally give you some sort of contextual meaning. If you're asking something, say for example, what is the capital of India, it will be recorded into a wave file. It will go to DeepGram server, converted into a text file. You will receive back the text file with some sort of the time stamping and everything, maybe the voice intelligence, sentiments of the voice. The DeepGram will give you a lots of information in terms of what was the tone of your voice, basically the sentiment, whether you were neutral, whether you were happy, whether you were angry. It will also identify all those things, and the text file will contain all these information once it is stored. So now we have received the text file or maybe a summary from the chat gpt of all the conversation, or whatever question has been asked during the conversation, it will give you the answers to. And now we need to play it back on the device which we are wearing. So whenever we ask a question that tell me about my 6 months of conversation summary, whether what was my sentiment, whether I was angry, whether I was neutral, whether I was happy, etc. So you will get all these through 11 labs. So 11 labs will give you a kind of audio output, and it will send you a wave file, and wave file will again be stored on the memory card on the ESP32 board. So the DF robot which I'm using here. So that is one way of doing a kind of using an edge computing device or a tiny machine learning device or a very small resource constrained device and using generative AI on that. So we are running everything, but we are using API calls, we are using number of API services, and finally we are able to do this. So let me show you the demonstration first. It has been programmed in Arduino. Right now it has been connected. If you can see my screen, let me start it again. So right now the board is not connected. So if you can see that it shows Wi-Fi connected. Even I have like added number of features into this one that I can get the timestamp, the date of today. Right now it shows the different, yeah, Monday, September 8 is correct. Time is not correct because I have not converted into an IST time. It's basically a GMT time being shown using the internet time zone servers. Now what I will do, I will store the audio for say few seconds. I will ask a question. So if you can see my camera, I'm going to press the button to record, because until and unless you do not keep the press button to record, it's going to record all the things all the time and it's not going to work. And that is why whenever we want to record it, we will press it. So say for example, what is the capital of India? Save to wave to SD card. So a file which has been recorded has been saved. Now it is sending it to the DeepGram server. So the wave file will be transferred from this device to the DeepGram server. It will be converted into text or transcribed. Maybe sometimes it takes time, or I don't know, sometimes it gives you an error also, but I will try again and you will be able to get the answer. Okay, so we got something from the deepgram, the detected language. Right now, it's not given. Sentiment is also not received. And here it has taken the language because I have changed the settings to Spanish language and it got something different. But again, TTS we have saved, that is through open router. So what I will try to do, I will record it again, or I need to change the settings into my deepgram server. What is the capital of India? Okay, it's doing again. What is the capital of India? Let me open this deepgram account and I will show you. So everything is recorded properly. So it shows my internet is poor and slow upload, and that is why there is an error message. But what we get usually, because right now my DF board is connected with my mobile phone's hotspot for the Wi-Fi. And finally, whenever we get all those things, if you look at the memory card, we open the memory card, connect with the computer, you'll be able to see that the answer from OpenAI router has been received into a WAV file format. Even the sentiment analysis and everything is possible through this one. So now coming back to the PPT and show you how it works again. And there is another option of using ESP32 instead of this sort of DF robot. I have another option of showing you just for your students project. If you're interested, you can use them for the students. That is basically a kind of a wristwatch. It's similar to an Apple Watch, not a kind of an Apple Watch. It is just for like 3,500 rupees, but you can use because it has an inbuilt ESP32 microphone, loudspeaker, memory card, everything on board. So you just need to wear it and talk to your watch and you will be able to get that. And this is the box. If you purchase it, is by Liligo T-Watch S3 basically. And it gives you all the option to program. You can program it using Arduino board itself. Arduino's IDE, I should say. So this is the one detail about the ESP32 T-Watch S3, where you get everything. There is another variant of this one which has an inbuilt GPS also. So maybe you want to record, or maybe you can ask your wristwatch that, okay, what I talked near Sindhu Bhavan Road on Saturday. So if you are there, it will identify the GPS log and everything. And basically based on that, it will be able to provide you the context of the conversation. So in short, like if a student is wearing this watch in the classroom, he will not have to take any notes. What teacher is teaching, everything will be recorded. If the permission has been provided by the teacher to record the audio, then he will be able to record everything. It will go to the DeepGram server, will go to the chat GPT, will give a summary of the what teacher has taught in the class. And finally, he will be able to even recall at some future time whenever it is required, maybe during the preparation of the examination, etc. So that is how it works. And I have created a very simple demonstration video So this was again generated through AI. I gave some prompt about this project which I was demonstrating, and it was like just we got back in terms of all these video kind of a format. Anyway, so that was the first example of how we can use a normal ESP32 board, which has a capability of running machine learning models, and even to access the lots of generative AI capabilities of various services. So in this example, I use services like DeepGram, Open 11 Labs, as well as OpenAI. So all of these three communications were happening with those three different servers through this board's Wi-Fi, and it was capable of doing everything successfully like a computer. So that is what the tiny machine learning or maybe the edge computing is all about. Now, another example I would like to show you here is I usually show this to the students, basically that how you can use or maybe identify various smells using AI. So like usually what we have done so far, that as a human, we have all the intelligence, like we have number of sensories. We can classify even the smell. If something is being cooked in our home, we can identify what is being cooked and what is the name of that particular recipe or maybe the items which we are cooking. So how we can enable such thing using the same classification of various smells using a tiny machine learning model, or how we can do that. So that is why I have prepared a 2 3 slides of that, and fundamentally it is all about the human olfactory system, that we have some receptors, and from receptors the brain actually identifies various different smells. So how we can achieve such thing, I will go quickly with some of the slides and will show you how it has been done so far. Yes. So this is what I did when I was at Northeastern in Seattle, and I will show you. So this is what you can call it is an AI sniffer. AI sniffer is like a dog who can sniff various smells. So dogs can identify a kind of, any explosive, but we cannot identify because we have limitations. So how electronic chip or maybe through sensors, we can identify various smells using AI, creating a small machine learning model, deploying it onto an Arduino, and finally we can find it out. So here I have used a VO terminal and some sensors from Grow. These are all basically Seed Studio sensors, multi-channel gas sensors, SPG and CO2 gas sensor, as well as temperature, humidity, and pressure sensor. Why we have used temperature and humidity sensor here is because every smell is dependent on the humidity as well as the temperature. Usually what happens when there is a rain, we get a smell of soil and everything. Just because of the humidity is very high, we are able to smell those things, and that is why for every smell the humidity matters a lot, temperature matters a lot, and basically when we are taking number of readings all together, we should be able to find it out. So I will show you these sensors, what these sensors are capable of doing. This is a Grow multi-channel gas sensor which can give you CO, nitrogen dioxide, ethanol, hydrogen, ammonia, methane, and or all other various gases into a single board. And even multiple gas detection can be done through this one. But very important part is basically the volatile organic components. Whatever smells, whatever things we smell, that is just because of the volatile organic compounds. It means that whenever you cook something, there are VOC particles which actually travels through air and it comes to our nostril, and finally we are able to understand those things. Things which cannot generate VOC particles, we can never smell them. And that is why we need to have a VOC sensor here. This is one of the most interesting and important sensors for identifying various smells. These sensors are not capable of finding out the smell, but it can give you the VOC level of different smells or aromas. Say, for example, if you have a coffee cup, you put the VOC sensor over there, you will get some data on the serial monitor of the Arduino. If you put a tea over there, you will get a different reading for the VOC outcomes of those tea fragrances, everything. So this is the most important sensor. Fundamentally, it is basically giving you an output in terms of volatile organic components as well as the ECO2 kind of a thing. So equivalent carbon dioxide value. And this is another sensor which I use for temperature and humidity because we want to measure it. Say, for example, to create a machine learning model, you might have recorded number of data. So maybe right now in this room, if the temperature is say 24 degree, and if I put a coffee cup here and take the readings of those coffee smells through VOC sensor, it will record with the temperature of 24 degree. Now, if I train that model, put it onto an Arduino chip and run it somewhere else in the 40-degree, it's not going to work. So I need to have a variety of data. More the data you have, more the diversity you have, more the accuracy you will get. That is how it works. So you need to record into different temperature conditions, different humidity conditions to make it more universal, and it should work in any of the scenarios. That is how it works. So this is something, the hardware connection what I have. This is the VO terminal basically, which you can connect with the sensors. And it is again, you can connect with Arduino IDE and connect it. So it's basically, I call it as a sensor fusion. So you have various different three types of sensors. You are collecting those data and finally you are classifying them. So in general, the fundamental scenario is basically what we are going to do is classifying the sensor data in terms of various smells what we have actually stored the data or collected the data and trained them and created a model for that. So it is for various, spirits, like whenever you have different spirits, you can even identify the VOC because every spirit has a smell. And whenever you get it on the serial monitor, you get the timestamp, temperature, humidity, and CO2, VOC1, VOC2, nitrogen dioxide, ethanol, carbon monoxide, all of them. So you need to just put it for a few seconds, collect all the serial monitor data, put it into a CSV file, label it as a like coffee, and again do it for say tea or maybe some other materials what you are trying to test or classify for various smells. And then we will do the classification and we'll do a kind of a machine learning for those different smells. And the best part which I use for here is like I use a Age Impulse platform. I think many of you will be aware of using that. It's a kind of a no-code solution. You just need to upload the data. So if you look at the collected data for tea, chamomile, kind of a very different fragrance of tea, the data were collected for that. The data were collected for various different tea smells here. And then finally, we need to do classification. If you don't know AI or machine learning, it will give you a guidance in terms of what sort of data you have. It will provide you a kind of a hint that you need to do Keras classification model, neural network classification. If you want to do anomaly detection using K-means clustering, you can go for that also. And finally, you go to various steps. Like if you look at the left side of the screen, initially you have a dashboard, then devices. If you have connected your device directly with the Age Impulse through your computer, it will start recording the data and it will upload. If you have a CSV file, you can upload the CSV file to the Age Impulse platform and you will be able to create it. And finally, it comes to the impulse design. Impulse design is nothing but creating your own model or making a doing the training for those data. So go one by one. If you want to flatten the model, if you want to do neural network classification, if you want to design the different layers as your own, by default, the Age Impulse will create a model, training model, and it will give you various parameters. So for example, in this case, the default value of the number of training cycle was 300. You want to change it to 500, you can do it manually. Otherwise, it will optimize and identify number of layers, dropout layers, dense layer, etc. But you can definitely change them and you can edit the code even. It will show you the code for these buttons which are being displayed here on the screen, and you will be able to modify that as per your requirement. But by default, whatever Age Impulse gives you are mostly the optimized ones. So there is no much scope available in terms of improving the model. And once you do, you can see this sort of, confusion matrix, even the classification and everything. Here, the accuracy is also being shown. So without writing a code, you can even create a complete model. If your data is ready, within few minutes, you will be able to run the model on the Arduino Nano itself. So once you are done with the classification and training and everything, it shows you on which board you want to deploy your model. So it gives you in terms of, say, for example, if you want to create a C++ library for your model, maybe a normal model, you want to run it on your computer, you need to download the C++ library. But when you want to use it on Arduino, it should be a kind of a, um, I should say, transformed into a very smaller size or truncated model, which will basically give you a very smaller size of the model. If you are using some sort of NVIDIA platform like NVIDIA Jetson Nano, you need to convert into a Tensor library, Tensor RT library, because NVIDIA supports Tensor RT only. Or maybe if you have another board, you can even explore those variants and you can create a library. So whenever we will create it for Arduino, we will basically get a .h file. It would be a .header file kind of a thing, and you need to import into your Arduino code and you will be able to get it. So when I tested this with the coffee smell, I put all the sensors inside a bag, because usually what happens that because of the air or the ambient condition of the environment, the smell is not that much prominent. So if you want to provide this sort of smell, because these are machines, these are sensors, they don't have human sort of intelligence, but whenever you put it, it will show you the accuracy that it is 97% coffee. Maybe when there is no smell at all, we need to collect the data for background also. Background is something ambient kind of a smell. Whenever we enter into home, maybe whenever we are sitting at some places, there is some normal smell which is existing. It cannot be of any of the material or maybe of any of the object, but it could be a normal background smell. And that is also we need to collect, because whenever you are not putting any of the test condition, it should show you that okay, there is no smell at all. So I'm displaying here background, but that means no smell. 80% there is no smell found in the environment. So again, if you improve, you can get 99% of accuracy. It was done for various alcoholic content also, so it shows you various combination that coffee was one, but for other spirit, gin, etc., it was only zero because it was not there in the room at that time. And if you want to learn more about this one, you can refer Benjamin Kobe's artificial nose project. I have taken everything from that particular project and has made my own kind of a collection of the data for various objects, and it was working perfectly. And you can even make something else out of this one for, say, for example, explosive detection or anything else. And you can make some devices which can be useful for the military purpose also. So this was one demonstration. But before moving to that, I will show you another one, how various devices can be used for tiny machine learning, as well as you can use it for your own projects. I'm not going to cover any AI/ML fundamental part here, but I will show you how you can do it. So this is one of the everyone's favorite Arduino Nano board, which is a little bit different than the normal Arduino Nano. It is basically 33 BLE sense, which has number of onboard sensors. So for machine learning applications, it is better to use this board because it has a capability to run this board, because it has almost 256 kilobytes of RAM, and it will be able to run everything perfectly because most of the models are of 8 kilobytes. So if you look at the board, it has color sensor, brightness sensor, proximity sensor, gesture sensor, digital microphone, motion, vibration, orientation sensor, so a kind of accelerometer, gyroscope, temperature, humidity, pressure, and everything on board. Even it has a Bluetooth on board, so you can connect with your mobile app if you're trying to transfer the data through that. So whenever we use this board, what we try to do, say for example, if you want to make your own Amazon Alexa kind of a device, the yes and no identification or audio classification, who is speaking in the family, what language being spoken, this sort of experiments you can perform with collecting the data through this microphone, and you can even classify them, and it works perfectly on this board. It comes with a camera also. So I will show you this board, and the camera module comes with that. So this is basically the board which I have right now connected with my computer, and I'll be able to show you that too. So this is Arduino Nano 33 BLE Sense, which has number of sensors on board, microphone, and all those sensors which I show you. And this is the camera module which comes with that. So it comes with a kind of a development board. You fit this board onto the development board, and you can connect this camera. So you can even develop a computer vision based application. You can even take attendance in the classroom by collecting pictures of the students, and automatically it will log into a CSV file, and even you can find out number of things, or maybe the classifying various students, etc. Let me go back to the slide. So even you can do object classification or object identification through this camera. Right now it is through a screenshot of the mobile app, but even you can use the TensorFlow Lite model on the Arduino Nano board itself. So if you refer a link on the TensorFlow.org for microcontrollers, you'll be able to get all these examples which I'm right now showing you. It can help you to even classify the speech. Even you can find out a person identification and other experiments also. So this is the board which I was showing you in a very close view. If you can see the blue square, that is basically microphone. Yellow square is basically motion, like 9x is IMU. And green is temperature, humidity, and pressure sensor in a single sensor itself. Now going back to this slide. So how you can run this, what setup you need to do. Initially, you connect your Arduino Nano 33BLE with your IDE and find out this board. Go to the board manager and find out that. And once you get that, install that board. And after that, you need to install the library for various sensors. So for IMU on Arduino Nano 33BLE, you need to search for LSM9DS1 library. For microphone, you need to search for MP34DT05. Everything is provided on the Arduino website, but just showing you that to make it run on the Arduino itself or the ID which you are using, you need to install all these library. Even you can find out gestures like left, right, up, down, close, far, etc. Pressure sensor, usually we don't use it for most of the projects we make. But digital proximity is very important. Ambient light is also very important. Even without the camera, you can classify various fruits. Like say, for example, banana is yellow, apple is red. So using color sensor, even if you can make a color classification model, whenever you put that particular fruit close to the board, it will identify the color and it will tell you. But it may not work for all the fruits, because if you show an orange, it will tell you a banana. So you need to, like, collect number of data and identify various colors in a number of data should be provided. And how we can collect all these data. So if you know machine learning, if you can program them, if you can collect the data, train the model, then it is fine. But if you don't know, you need not have to worry, because Age Impulse is one of the best platform right now. Without coding, you can do everything. And even if you don't know what next step I should do, it will tell you what you have to do. So if you go to Age Impulse website, the first thing is that collect the data. And if you don't have a sensor, even for example, right now you want to make an accelerometer project, you want to collect the data for various motions or maybe various gestures through accelerometer. You are generating some data and you are collecting those data, and you don't have an Arduino. So what you can do, you can connect your mobile phone through Age Impulse, because it gives you an option to connect your mobile phone also. It will show you a barcode. You just scan that barcode and your phone will be connected with the Age Impulse account. Now you just move your phone, because it has an accelerometer inbuilt inside the phone. You will be able to generate the sensor data, and it will transfer automatically through internet, and it will be stored over there. And then you will be able to classify them, train them, and you can even deploy them once you get the trained model on the Age Impulse platform. You can download it for Arduino, you can download it for Jetson Nano, and then you can use it. So this is the first home page. Whenever you create your Age Impulse account, it will ask you to select the project. If there are no project existing, you need to create new project. The project will be created, and then finally it will ask you that what sort of data you have, whether you have an accelerometer data, whether you have audio data. Say for example, you want to do classification, that on DD News we have various channels like DD Gujarati, DD Punjabi, DD Odia, DD Kannada, etc. You are recording some audio from those news clips, simply downloading into an MP3 format or maybe a WAV file. And you want to classify that if someone speaks in Kannada, my board should be able to tell me that this is a Kannada language or maybe this is Gujarati language. So in that case, you can use the audio option. If you have various images, maybe you want to classify all the students and you want to identify the students with their enrollment number or maybe with their names, or maybe you want to connect with the GTU result website. So enrollment number will be identified for that from the student face. It will go to the GTU website, it will fetch the result, and you can even identify just by putting a camera in front of the student face, you'll be able to get the result of that particular student, that how many backlogs the student is having. And even you can fit it into a wearable glass, put the Arduino camera, everything inside a 3D printed wearable glass, go to classroom, and it will tell you in the audio format that, okay, this student has like almost 9 grade, this student has 2 backlogs, etc. So you can make some innovative projects using this one. And even if you have something else, you have other options to do that. So here, this shows that, okay, once you have already collected data, then it is fine. But if you want to collect the data through Age Impulse platform, you have all the options that you can use your mobile phone's microphone to collect the audio data. You can use your mobile phone's accelerometer to collect the data. You can use your mobile phone's camera to collect the data. So even a single mobile phone will serve the purpose of Arduino or any development board. You don't need to buy anything. Initially, you can start with your phone and you can even transfer the data to Age Impulse platform. If your computer is connected with various sensors, maybe through USB or maybe through other options, you can use your computer to collect the data through webcam, through microphone, even you can connect that too. and data from any other devices with data forwarded, because if you have a kind of a instrumentation process where data forwarding mechanism is there, which will forward all the data to the USB port, you can connect that. If you have a CSV file, JSON format, PNG, WAV, or MP3 file, you can upload all these together directly from the computer. So it means it gives you all the options to play with the data. And then after, you need to set up some sort of command line interface into your computer, download some dependency based on the GitHub link provided on the Age Impulse website. Your computer will be ready for any of the tiny machine learning project. So these are the things you need to install on your computer. Like if you are using Windows, you need to install Python 3, Node.js, some Windows user for, like, it will ask for some additional dependency, and maybe finally the command line interface tool via npm install for Age Impulse CLI Force, because that is the proprietary installation required from the Age Impulse platform. Because finally you are going to connect your laptop, maybe you are going to connect your mobile phone with the Age Impulse platform, and that is why it is required. So these are the steps where these are the libraries available. If you go to Arduino's website, you will get all the details. So there is a complete wiki available. You can refer that. I just put the screenshots here just to show you that where you can download Python, from where you can download Node.js, etc. These are very older screenshots, maybe taken few years back. So now it must be updated one. And how you can collect the data or sensor data from the web browser, that is also an option. So what I will show you here, say for example, right now I have connected another Arduino board with this one. So previously it was connected with that one, but I also connected an Arduino with my IDE. This is connected. So now I will take this one and I will show you. See, if I'm moving this board, it generates number of accelerometer data, because it shows me the AX, AY, AZ, means acceleration in X direction, Y direction, and Z direction, as well as the gyroscope data, GX, GY, GZ. So all of this data can be available here. Now, if I do a gesture for 0, for example, if I do gesture for 1, if I write something like A or B or C, and if I collect number of data from different people, from myself, with a various different, movement, say if I write A, someone can write a very big A. So I need to have variation in all the A which has been written in air. And if I collect the data through serial monitor, copy them and put it into a CSV file. And if I give a name to that CSV file as A.csv, so it means that these are the data of accelerometer for a gesture of A. If I do something for B, if I do something for C, or maybe if I do any other gesture, like say I do something like drinking, I do it for say 50, 100 times, I will be able to generate the data and I will be able to finally classify them through the Age Impulse platform. So the method and process will remain same. Instead of classifying the audio data, you are classifying the sensors data, and finally you are creating a TinyML model, which again you can deploy it onto a uh, Arduino Nano 33 BLE or any other DF robot boards which you have. So let me show you a waveform of this one, if I can show you here. So even you can see the patterns of the data whenever you are moving your sensor or accelerometer. You are able to see that some continuous patterns are being repeated, and that is what basically we try to identify through this classification or maybe any machine learning model. Right now it is not showing me. Let me do it again. See, if I do something like this one, it show me a continuous pattern. If I do something like this, it will show me a different pattern. If I do horizontal up down, if you can see that the value of different like AX, AY, AZ being changing. Right now, the pink color is basically prominent in terms of this waveforms. But if I change from horizontal, it will change me, it will give me a different sort of waveform. So basically, we are trying to find the patterns from the data and we try to find out gestures. So if you look at your Apple Watch or any of the smartwatch which you are wearing right now, whenever we do a gesture like showing this one, it glows the LED. So basically, there is a ML model which is running inside this smartwatch that whenever we do a twist of the wrist, basically it will enable that LED backlight and finally we will be able to read the time. So that's the best example that you can show your student that maybe how you can enable something with a wrist movement or maybe through any of the different motions or gestures, and that is how it works. So that was one example for this one. And again, I will show you another one which is already there on this one. So a few years ago, like when I was at VGEC, we had won a global hackathon for identifying mosquito wing beat sounds. Through wing beat sounds, we were able to identify the mosquito species. So let me tell you briefly about this project. We actually downloaded a data set of various mosquito sounds in terms of wing beat sounds. I mean to say the when the mosquitoes are flying, they generate some sort of sound because of their wings, because they are flying very fast. Every mosquito having a different species are having a different frequency of flying at some different speed, and they all are different. So what we did is we collected all these different sounds of these mosquito species like Aedes aegypti, Anopheles, and Culex. We tried to classify these different wing beat sounds, and we were able to generate with a 79% of the accuracy for different audio of the mosquito wing beat sounds. And we actually deployed that onto a device. And finally, whenever there is a mosquito flying in the home, it will show you the name of that particular mosquito species, that you have an Aedes aegypti, or maybe you have a Anopheles, or maybe you have a Culex, etc. And if you integrate with a Google map, and based on the locations of the sensor, instead of showing a traffic on the Google map, you can show that, okay, there are lots of mosquito breeding of Culex into say Motera area or maybe Maninagar area, etc. You can show a kind of a density of the mosquito species at different areas in Ahmedabad. So that is how you can create a mass impact for. But the fundamental concept was simply collecting the audio data and classifying them through edge impulse. There was no coding done. Directly, we uploaded all the data of various mosquito species. And finally, we did classification. We created a header file. We deployed onto a tiny machine learning, and finally, it was running well. And that was perfectly a project which was demonstratable. And for the similar way, again, there was a project done for kind of a baby cry identification. I think I posted a few days ago on the LinkedIn. So we collected various baby cries. Usually what happens when the baby is in infant stage, the communication is only the cry. If the baby is hungry, the baby will cry. If the baby is sleepy, it will cry. If the baby is, having some sort of discomfort, it will cry. But how a parent can identify? So if you consult a pediatrician, they will be able to tell you that because they have an experience, they know that what could be the reason and what is the different pattern of crying for the different babies. So we collected from YouTube videos of various baby cries, converted into an MP3 file, and again classify them using the same method of age impulse. And I will show you that particular video which I recently demonstrated on my campus. If it works, then it is fine. So if you see this, right now it is recording. It is hungry. There is another video for discomfort as well as, sleepy also. So you can even find out, and it is the same board like Arduino Nano 33 having a 0.9 LED display and a battery inbuilt in that. And it will finally be able to identify various, audios. So it is simply an audio classification problem. But it is all about creativity. It is all about the way you try to classify the data. So I would recommend you that, use the same thing, but you can even try to use some creativity out of this one and you will be able to use it. Okay. Now going back to the slide. So this is the process of installing the libraries for TensorFlow also, because when you use Arduino Nano 33BLE, you will have to install the TensorFlow library. It is by Google, but you need to install that for your Arduino IDE and you will be able to good to go. And there are few examples ready-made available by the Arduino itself. So you go to the Arduino playground, you'll be able to identify some source code which are able to capture the sensor data for accelerometer or maybe for audio, etc. You start capturing them through the serial port. These are the waveforms which I was showing you. Say, for example, if you're simply moving or maybe creating some gestures, you can record them. So in this example, I created only the left side movement of the sensor or maybe the Arduino board itself, captured the data for at least 10 times. Even having very small amount of data will be able to work very well because they have a quite difference in the sensor data collection, and that is why only 10 readings will also do. So give it a name like left.csv, right.csv, or maybe 1.csv, 2.csv, 3.csv, etc. And if you use this sensor and do fusion with some sort of magnetic field data with the earth, you can even create some sort of interesting projects out of that. So when you start recording the data from the serial monitor, you will be able to see that all the columns, comma separated values are basically for AX, AY, AZ, and you need only that. There is no need of GX, GY, GZ into this one. But if they are also with that, it will give you more accuracy or maybe a better outcome or the result of the gestures which you will try to test later on. And the problem with the serial monitor is that it doesn't allow you to, record all the readings altogether. So whatever has been visible on the screen, you will be able to just select them and copy and paste it. So you need to do it again and again. It will take, so it's basically a time consuming process. Maybe you have recorded for 2-3 seconds. So maybe your serial monitor will scroll up number of data altogether, but it only allows you to copy which are available or visible on the screen. So you need to first capture this one, then go to the next part of the data and then copy. So it will take some time, put it into a text file initially, and then save that text file as .csv file. Then you will be able to open it into a Excel format. Or maybe you can use Google Colab also after that, how you can train the model. So that is how, if I can open this and if it is over there, I will show you how it works. These are all ready-made sample codes which are provided by the Arduino itself. So it is already there on the internet. You can just use them. All the data, the file which you have, you need to simply upload them onto your Google Drive, because whenever you are using Google Colab, it will not allow you to save your file of the data. It will save your code, but you need to again upload the file. So if you look at this file name punch.csv, so what I did, I recorded like this one, holding the sensor and punching something. I recorded those data. I call it as a punch.csv file name. But now the file is not here because it was done few years ago. So I need to upload that file again through this option. It gives you an option to upload the file from here and you will be able to upload that file. So whenever you close your Google Colab, it will actually remove the file which has been uploaded. So that is the only thing you need to keep in mind. I will share you all the codes and everything. If you are interested, you can even classify, you can create your own model and you can run them. But you need to have a kind of a board at least to deploy on hardware. And these are the examples of Arduino TensorFlow Lite tutorials, which you can refer as a beginner if you are just starting. So it gives you a gesture to emoji. So maybe you are doing a gesture like this one. So it will show you a kind of a converting into an emoji of waving a hand. So maybe that is also possible by writing this one. So these are the examples provided here, like fruits to emoji. If you identify a banana or an apple, it will show you an icon of those things. All these IPYNB file are available, so you can use that interactive Python notebooks. So I will share the slides, so you need not have to even record all these. Everything will be available and you can even use these slides for your own projects as a beginner. Those who are already working must be knowing everything, but just for some of the audience, it would be useful. It takes time to load. So this is inside the Colab which I was showing you. I have taken all the screenshots. So maybe sometimes if it is not running, I can show them. So once you will start install all the required libraries like NumPy, Matplotlib, and TensorFlow, it takes some time, like few seconds, because you are already running on the Google TPU. And that is why it will not take much time. If you have like locally running installation of all these Python libraries, it's going to take too long time, and you will be getting lots of error also. And you need to install some dependency packages, etc. It's going to take too long time. I would recommend you to go and do everything on the Google Colab. So here, how you can upload the data. Once you upload the data, these files will be visible here, like flex.csv, punch.csv, and then this is the code by which you will be able to, I cannot explain everything right now in a just 1 hour of session, but you can refer this later on. So initially it will show you the recorded data which you had recorded for some sort of activities. So this is just reproducing what you have done so far. And finally, the steps is to train the neural network based on the CSV data. You can even randomize the split input and output pairs of training, build and train the model. Again, you can verify with the gestures, again, by doing that. And finally, what you will get is basically a file. You can name it as a model.h. Basically, it's an header file. So whenever we use Arduino boards, we include header files. But here, when you include the model.h, it is basically a tiny machine learning model. It is not a normal header file which you use for your Arduinos. So that is the model.h file. You need to add file, go to an option into the Arduino like tools and add files. And from there, you will be able to get the model.h from your computer, and it will show you like in a binary format, hexadecimal format. And once you run that model, like model is running on the board itself, now it will not show you the data because initially the program was written to capture the data, but now we have a ready-made model which is running. So whenever you move it, it will show you the accuracy like left. If you do it on left side, it will show you 99%. So maybe 0.99 shows you that it is the accuracy that you are having a correctly running model and it is having a perfect accuracy. But you need to do it for various different gestures, and even you can do it for a number of things altogether. If you don't want to record the data, I would recommend you to go to kaggle.com and even try to find out some available data set like human activity detection data sets. You will get lots of interesting data from that human activity data set. So these data have been collected through mobile phone or smartphones, and it gives you lots of various attributes which you can use them. So if I go to the file here. So instead of recording your data at your own, you can directly use the available data. Show you what are the different data available, train data. So it has 126 columns. Sorry, 1,126 columns. I just want to show you what are the different attributes in the data. So if you look at this, all the data are for various human gestures, and maybe there would be a label for that too at the end. When you have such big data, you need to use Google Colab for everything, and you can do classification. So if you look at any of the data science problem, say this is the activity. When the person was standing, this data was recorded. So all these are basically labeled as a standing data. These are the seating data, lying data, walking data, sleeping data, walking downstairs. Even you can find out whether the person is going upward in the stairs or downstairs. Standing, sitting again. So for various different users, that data have been collected. So then once you have this sort of data, you will be able to classify them. And if you look at the record, how many data, there were like 1100 columns. When you have such big data, you should use Google Colab, because normal computers either they require GPU or maybe it will take time. So even though you don't want to record the data through any such Arduino boards or accelerometer, you can use such data to do machine learning. And then once the model is created, so the beauty of tiny machine learning is all about when you have a huge amount of data. If you do normal machine learning for computers, it will give you a model of say 150 MB size. But when you do it for TensorFlow Lite for microcontrollers, it will give you just a 12 kilobytes of size. So all the data now converted into an intelligence, that is basically a small model which will be able to run on any of the devices like ESP32, Arduino, Jetson Nano, whatever it is, it will be able to run on those devices. Going back to this. So this was about tiny machine learning or fundamentals of age computing, how we can do it. The only takeaway of this session is that whatever we do it for computers, it is all about huge amount of data or big data we use. Lots of data sets are available on the internet. But when you want to use it for embedded systems, or maybe any of the electronic chip, you want to make your own devices, maybe a CCTV camera. It is not a computer. CCTV camera also can also run the machine learning model inside that. It can also identify various objects automatically because there is a tiny machine learning model running into the CCTV camera. So that is how you can do that. So the first part was all about using different boards. So I show you a kind of a TTGO Liligo watch, which you can use ESP32. It has also a camera. There is a DF robot board, which you can also use for tiny machine learning. There is Arduino Nano. There is a VIO terminal with various sensors, which can also run machine learning models. So whenever you run it, all these on the such devices, that is basically the TinyML or edge computing or sometimes physical computing. If you refer to the Harvard University course, in the master's program, they have a dedicated one course on TinyML itself. And the kit which I show you, that is by Dr. Janappa Reddy, who has actually designed that kit, and now it is available. Even you can apply as a faculty grant also to the Age Impulse Foundation, and you will be able to receive those kits. I think I have received it for 3 times. There's normally send 10 different kits. Recently, I received this one, the Seed Studio kits. They are basically ESP32S3 having a camera module, Wi-Fi, antenna, and everything. And even that can also be used for TinyML projects. So now we have, I think, half an hour of time. So integrating generative AI is a completely different call. Usually what we do, we understand generative AI is all about kind of a chat GPT, but generative AI is completely different than whatever we are understanding. So I will show you some sort of LLM fundamentals that how as a beginner you can start with working with the generative AI. This is a kind of an era where we do API calls most of the time. So we cannot build a OpenAI kind of an infrastructure. None of the company in the world, like only Microsoft, Google, OpenAI, or maybe Perplexity are having their own infrastructures by which they are able to, the collect huge amount of data, run the model, train them, and finally providing all these intelligence. And they consume a lot of energy, they use a lot of data, they use a lot of bandwidth, power, everything in terms of storage devices, which normally a kind of a company or a government cannot afford because there is a huge investment of all of them. But if you want to make your own chat GPT, for example, or maybe your own OpenAI kind of a facility or server using a text file. Maybe you have a book, say for example, a PDF file. If you want to create a kind of that sort of interface, it is necessary to understand the fundamental how the journey started actually. So it all started with the NLP, natural language processing. So I will show you some slides quickly because we have only half an hour of time, but that will at least give you a kind of a glimpse of fundamentals of LLM and the story for generative AI. So basically, what is large language models? They are basically the neural network designed to understand, generate, and respond to human-like text. That is basically the large language model. Nowadays, people have started talking about small language models. So if you just research and search on internet, you will be able to find out something where now people are not, everybody cannot handle LLM infrastructure. And that is why people thought that let us have a small language model. And now these days we have SLM also into the market, and they are basically customized, application oriented, and based on the requirement people use them. So whenever we understand anything about the generative AI or LLM fundamental, every time you will see that you are using ChatGPT, you are asking some questions. Everything is basically tokenization. So whenever we are like sometimes ChatGPT gives you a limit that now you cannot use ChatGPT because your limit is over. That is basically the token count. So whenever we give a sentence, we get the answer. ChatGPT servers basically count those tokens, and tokens are nothing but a kind of a word or a subword. So in this example, like NLP is written natural language processing. So natural language and processing are known as basically tokens. And these companies are basically charging you based on the how many tokens you are using. So maybe like 1 million token a month or maybe 1,000 tokens per day, etc. Once you are utilizing those limits, they will not be you will not be able to utilize those facilities until and unless you are having a subscription with them. They will give you all the access of using more and more tokens, and again they charge you. So whenever I show you that first example of deepgram server and OpenAI and the 11 labs and everything, I have actually my account, and every time I send some sentence like asking what is the capital of India, it actually reduces those tokens from my account, and finally I will have to pay for that. So this is not a kind of a free be kind of a thing when we talk about generative AI and everything. It is all about making people habitual about using them, and later on you will not be able to live without that, and you will definitely pay with that. And you will be surprised to know that recently OpenAI announced for India that you will have a 390 rupees of license. That's a kind of a limited version of GPT-5 model. But on the day one itself, they generated a huge amount of revenue out of Indian users. And that is how, for 1 year, they allowed you to use it for free. And now just for 390 rupees, because you have been habituated, you are dependent on those tools, AI tools as an aid, and now you will be ready to pay those things. So NLP is all about starts with the tokenization, and token is basically a single word. Then we do stemming into the NLP. Stemming is something reducing the word to an original format. So if you take a word called running, to save the time, to save the memory, to save the processing capability, we transform them into its original format, and that is basically run. So if I'm say singing, so it will convert into sing. Similarly, all these words will be transformed by the method of stemming. Then comes the lemmatization. So lemmatization is all about reducing words to their base from using vocabulary and grammar rules. Say, for example, better you can transform into good. So maybe each and every time you don't need to look for different words, but maybe a kind of a similar words from vocabulary and finding out various rules for that. So that is basically lemmatization. Then stop words. Whenever we write a one page of Microsoft Word document, is and the etc are of no use in the sentence. They don't show any meaning out of that. Even if you remove them, you will be able to understand, but these are basically the stop words which we understand for our normal human to human communication. But when it comes to NLP, we need to remove them, and that is why is and the all are removed when we do pre-process the data for generative AI or maybe for normal NLP project, and that is why they are known as NLP. So these are some of the terminology which I'm showing you to understand some fundamentals of generative AI, but it starts with NLP. Then comes the bag of words. Say, for example, I have a sentence called I love NLP. So I is one, love is one, NLP is one. So how many times a particular word is in there? So it shows you a count of the word into a sentence. If you have a word which is constantly being repeated, and if you can recall the Sundar Pichai's statement last year at the Google I/O event, he talked a lot of about AI all the time. And somebody posted after that, on the Twitter that during this half an hour of maybe or 20 hour of the speech, 20 minutes of the speech, Sundar Pichai spoke AI 200 times. And if you have like seen this type of the this time his presentation, at the end of the session, he told that I spoke this word this many times because my Google Gemini system will let me identify the bag of words into my total conversation and everything. So it is all about finding out a particular word count in a sentence, how many times it is being repeated. Order is not important. Then comes the FIDF, maybe term frequency, inverse document frequency ratio. It is all about the frequency of a particular word or a term and the total amount of words into that particular sentence, it is divided by that. So it is a ratio basically. Then n-gram is all about how many n words from a text are there. So if you have a sentence called machine learning, it is basically n equal to 2. So that n-gram word is also popularly used in NLP. Then it comes a name entity recognition. Say, for example, if you have a sentence called Apple is in Cupertino, that's a headquarter of Apple. So here the name entity recognition is all about identifying what is the context of these words. Apple doesn't mean a fruit apple here. Cupertino is a kind of a location. So this is called an NER or maybe name entity recognition in NLP. Then it comes a word embedding where you can have a dense vector representation of words capturing semantic meanings. So king and queen have similar embedding in a model like word to vector. But when it comes to a different thing, say for example, if you're talking about a sleeping bed, maybe king size or queen size applies to the same bed. But when it comes to a person, king and queen are different. So the semantic meaning or contextual meaning is very important in generative AI. Normally, it doesn't understand in terms of what sentence you have written, but the order is also very much important sometimes. Say, for example, if I write that Ahmedabad won over Gandhinagar. So NLP will identify or maybe separate all these words. But now if you change the order, Gandhinagar won over Ahmedabad, the meaning will be different. So that is how the NLP understands the contextual meaning of the sentence and how it processes all these. And that is why it is so much intelligent in terms of human way it understands it. It replies you in a human-like contextual, meaningful answers, basically. Then the sentiment analysis, it will identify the text from the sentence and it will identify. So in this sentence, like love is positive. So basically it shows you a positive sentiment. I don't like the smell, for example. So don't is basically a negative sentiment. So it will identify the sentiments also from the text. Then cosine similarity, that it identifies, the contextual meaning of the different words. So a measure of similarity between two text vectors based on their angles. So you need to identify the cosine similarity also. So now you can imagine that a single line, how it is processed, like lemmatization, stemming, tokenization, cosine similarity, word embedding, NER, etc. Every process will be done on all the sentences. And it requires lots of power, memory, and processing power to consume all this big text. Whenever we upload a PDF document, it takes fraction of second for the generative AI from the OpenAI to process those things. So now you can imagine how the models are accurate, how the models have been trained so far. Then part of speech tagging is also very important in terms of assigning grammatical categories like noun, verb to words, etc. So maybe dogs bark. So dogs is noun, bark is a verb. And that is how it identifies the grammars also from the part of speech which you are providing to the OpenAI or any other generative AI models. Word frequency, that how many times a particular word appears in a paragraph or a sentence, etc. Parsing is all about separating the text, what we do normally in any of the programming language like string parsing or sentence or object identification through the words. Then it comes the word sense disambiguation, determining which meaning of a word is used in a context like bank. But it is not a normal financial bank, it is a river bank. So contextual meaning is very, very important. And that was the biggest hurdle. But a lot of interesting word to vector research has been done. And that is why nowadays it identifies the perfect meaning of a particular word in the sentence. Then perplexity. It is a metric for evaluating language models based on how well they predict a sample. Lower perplexity means a better language model. So it is basically a score, and there is a method to calculate the perplexity also. So perplexity is not that website. They have actually taken the name from NLP because they are also into generative AI, and they thought that let us keep a name called perplexity. So the meaning of perplexity is all about the performance of the model. Lower should be the better one. Okay, now I'm not going to cover all this because this is a very long one, but I will show you one important slide. Okay, just for information that we all talk about, chat GPT and everything, and we feel that it has all the data which has been used from the internet, but they have taken only a very small amount of data from the internet. They are not able to harness all the data. No one has that capability in the world to harness all the data available on the internet and to train, because there are no such hardware infrastructure available. No GPUs are available that can, process all these data, or maybe it will take tens of years to process and train that model, but that is not possible. So right now, GPT-3, when it was announced for the first time, they released that what data they use to train that GPT-3 model. So basically, it's a common crawl data. So if you look at this number, proportion in training data was 60%. So they are basically web crawl data from the internet. Number of tokens, 410 billion tokens, web text to web crawl data, some books, internet-based books, corpus, as well as some other books to corpus. So like 12 billion for the first corpus and second 55 billion for that. That only contains 8% of the data in the GPT-3 model. And Wikipedia articles, like they are high quality text. So 3 billion tokens from that. And that contains only 3% of the total training data. So now you can imagine that it is a lot of data which is still not covered by OpenAI or any other, like Google Gemini or maybe Meta's Llama model or any other models which has been used so far right now or popularly available. Nowadays, people are able to harness or capture only a small amount of data from the internet. And again, there are lots of ethical AI concepts in terms of copyright issues, that without any permission, you cannot download the book, you cannot use the text. So whatever has been freely available, these companies are able to use them to make generative AI models. So these are the GPT-3 data sources. All the links are provided. And they actually use the book one from the Gutenberg project, and books two is from Wikipedia Library Genesis. And if you want to start as a beginner to understand everything about, I would recommend you to read this paper. Attention is all you need. It was by Google, and you can see there is one Gujarati girl also, which was like, one of the first one to write about generative AI concept. When Google released this paper, they were not aware about that, it is going to create a very big impact. So actually, OpenAI took this paper and they are heading in the world right now. Google was the originator or the innovator for the fundamentals of, GPT architecture. But because of, they couldn't use their own innovation, they couldn't use their own technology. So OpenAI took this paper and finally they started building the technology on that. And now Google is behind that OpenAI for, at least for the generative AI concept, because the concept brought into the market for the first time was by this team of 7 people at the Google Research Lab, and they had an amazing one. And if you want to understand this paper, there is a YouTube channel, Papers with Code. So even it will tell you how this coding is done for this particular paper, how you can implement this paper, and even you can refer that. Okay. There are lots of different technologies of the attention. I think I would keep it up to this much, because now it is of no use of explaining all these in, because they are very advanced version of the generative AI models. Okay, I think we are a little bit early to finish. So what we do, we will have some Q&A for 10 minutes and then we will finish. Janvi, are you there? If you can take the question and answer. I mentioned the papers with code.
So, yes, sir. Hello.
Papers with
Yes,
code.
sir.
Yes, I can listen, hear you.
Any question answer from participants?
Papers, code.
કરું છું.
See, this is the channel I was talking about.
Participants can unmute your mic and ask the question to the sir.
So this is the papers with code website where you can get all the papers. You can even go get all the codes on the GitHub repository or archive page and everything. So you just search the paper. Most of the codes are available. Usually they are not released by the researchers, but there is a repository which people maintain and write the code over there. Even there is
Hello,
a
sir.
repository. Yes, please.
Yes. Sir, what are the main risks associated with deploying LLMs in critical domains?
It is all about, first of all, open source models which you can access, like Llama and all of them. And the biggest thing is that most of the model, see, right now, I don't find any problem in terms of using them, or maybe any critical scenarios where you find a problem in using them, because all the models have been trained in terms of keeping in mind the ethical aspects of using them. If you try to ask any of the weird question to these models, or maybe you ask ChatGPT to create an image of some weird personality, it will not give you any answer. So it means that everything is built in the model itself. So there is no harm in using them, and nobody will be able to even play in that way in terms of negative sense. Or maybe, like, say, if you ask about that generate a video of president dancing or something like that, or maybe create a image of a person like this or that, you won't be able to do that because the models are trained like that only. And that is why whenever we are using an open source model, I don't see any harm in using them, because there would not be a problem, because everything is in the intelligence of that model, and there would not be a problem. Yes, any other question?
Hello,
People
sir.
will get. Yes, please.
Sir, what future improvements are expected in LLM research, sir? What are the
Future
future
improvement is all about, the biggest problem is all about handling lots of tokens and the pricing and the energy being, or maybe the resources being utilized. So nowadays, what people are trying to do is that, dividing such big LLMs into providing various services. Say, for example, if I'm interested in X area, then they have a kind of clusters of this sort of intelligence, that these queries will go to that particular part of the model only, or maybe that query will go to that part only. Say, for example, I'm asking scientific questions, then that will take care of that questions only. And that is how it has been subdivided. The biggest problem right now is that not a single organization individually can set up all these big things to run such big models, to train such big amount of data, and to provide the services, because there are like billions, trillions of queries are being handled by all these big servers. So right now the biggest problem is that how we can reduce this consumption of the power, how we can reduce the GPU utilization and everything. But this is basically a AI race. Everybody wants to be ahead, and nowadays, they are only interested in investing lots of money, that we want to be the first in the world, we want to control everything in the world using AI. And that is why there is a race among all these 3 4 big companies. And even the countries are also competing right now, that India is building its own AI infrastructure in terms of large language models. United States has already big companies having all these models and everything. So it is all about, it's a race right now. Nobody is earning. Even OpenAI is not profitable these days, having even this sort of biggest innovation in the world right now, a kind of a revolution, I should say. But still, they are not profitable.
sir?
Yes.
Hello.
Yes,
Sir, why
please.
Hello,
are
sir.
LLMs considered as black box models, sir?
I don't know why they are called black box model. Basically, they are already trained. It is in terms of, say, let us take an example of a gesture recognition model, which we are talking about today. Like we have number of sensor data for different gestures. We created a model. So we got a model.h file. Now, if you open that model.h file, you're not going to get any information from that because that is basically the intelligence what you have. So it is something like a black box. You don't know anything what is inside that because now once it is trained, or maybe you download a Llama model from Meta's website and you use it for your own applications, but you don't know what is there inside because the way it has been trained, the data for which it has been trained, what are the different sort of accuracies for various different sort of data for it which it has been trained, you will never be able to get anything. And that is why there is a concept of explainable AI. These days there is one community who is constantly talking about explainable AI, that say I have an Amazon Alexa at my home, but I don't know what happens to my audio, even how the model has been trained on which kind of a data. So now it is the responsibility of the company who is making any of the model, whether it could be a generative AI model or a normal AI model. They need to tell the user that, okay, your data is going to be utilized in this way, or maybe the model which is running in the device which is at your home, it has this sort of functionality of working, the steps in which the model works, how the data for which it has been trained. You should also be able to know that on which different voices it has been trained so far, whether the data contains for all sort of genders or maybe all sort of age groups, maybe people having some sort of speaking problem, or maybe disabilities, or maybe that has been trained for those users also. People should be able to know that. Say for example, I have a speaking problem, I'm like some sort of, I don't know the word, what should I call it, but I cannot speak very well in terms of any of the word. I take some time to pronounce that word. So if I buy an Amazon Alexa and if it is not going to work with my audio, then I should be able to know about, and that is why we call it as an explainable AI. There are lots of research groups working that are promoting, and these days companies are also telling you that how our models are running basically. But these days are also right. There is again a truth is that we don't know what is happening inside the model, and that is why we call it as a LLMs are like black box.
Hello, sir.
Sir, this is a repeated question, sir. You have explained earlier. Sir, may I ask you again, what are some real world applications of generative LLM?
You can search on internet, ask ChatGPT, you will get lots of answers. It is up to you how you want to use it. You just give me an area, I will be able to show you that how you can use it, generative AI. So if you have any idea in your mind, you just tell me how to use. I will give you the answer for that.
Sir, if we want to do the optical character recognition from the video, then is it possible with the ESP32 cam board or?
Yes, you can do that. You can do that.
So, sir,
It is
can you
possible.
suggest which model is helpful for?
See, initially you can start with YOLO, and there are lots of examples available for ESP32. So you can start with that, and then you can replace with your model. Or maybe I would suggest you to use Google Inception model. So Google Inception has been trained for, number of objects altogether. You need to simply fine tune the last layer of that Inception model with your data. So the example which I was explaining during my session, that, how can we identify the student's result from their face. So I use the Google Inception model for that, and I trained with those 20 students of pictures of various angles, through various angles, their facial pictures, and that was trained. But the model was Google Inception model. It was like already trained for number of objects in the world. Almost none of the object has been left out. But when we do retrain for our data, finally it will work for our own data only. So maybe you want to do optical character recognition, you'll be able to use it because the quality of the camera is also good. It's almost a 3 megapixel of camera which you get with this board. So I don't think so there would be a problem with that. Even like people are using it for microscopes also to classify, various things on the slides and everything. So they take pictures through ESP32's camera from the Microsoft itself, create a data set, and then do the classification with various Inception model or maybe YOLO or any other models.
Okay, sir. Thank you.
Okay, any question from participants?
Okay.
Okay.
So thank you for joining and listening. Though I had some sort of, jumping from one slide to demonstration and all different things all together. But my intention was just to make you aware about what you can do with all these, like maybe the TinyML or maybe generative AI or various boards available, because most of the faculty members or the participants would be from electronics and communication or computer science background. So it comes to, utilizing them. You just buy it and start working on them within half an hour or a day. Maybe you will be able to make everything in terms of working. That is how you will be able to do it.
Okay. On behalf of sir, every participant, I extend my heartfelt thanks to Dr. Kiran Trivedi sir. Sir, the way you connected cutting edge research with real world use case made the topic both engaging and relevant. We truly appreciate the time, energy, and the passion you shared with us today. Thank you once again, Dr. Kiran Trivedi sir, for enlightening us with your knowledge and leaving us with new ideas to carry forward, sir. Thank you, sir, once again, sir.
Thank you so much and good night to all of you. Thanks a lot. Should I leave now?
Okay, sir. Thank you, sir.
Bye.
Bye.
Thank you, sir. Thank you very
All
much.
participants are requested to turn on their camera for group photo. All participants are requested to turn on their camera for group photo. તમે કેપ્ચર દેખાશો તો એને બોલાવે. All participants are requested to turn on their camera. नहीं स्क्रू से भी करो. हाँ. तो देखो वीडियो लेना. Okay, you can turn off the camera. We took the photographs. Thank you. You may leave now. Sir, attendance ले लीजिए. Recording stop करें, sir.
Is there any feedback form, sir?
Yes, ma'am. Yes. Actually, feedback form is included in the attendance form. So you can fill the feedback on the attendance form.
Sir, is it available in the chat or you send it through WhatsApp?
No, you are not audible.
Have you sent it through WhatsApp?
Yes. Yes.
Okay, thank you, sir. Thank
कर दो लिंक बंद कर दो लिंक. And meeting.